I've given up on like stands and multiple cameras and stuff because basically it's just too much dicking around. Yeah, if I wanted to be a professional podcaster, but I don't actually. No, I just want to share stuff that I've got. I want to do it quickly and I want to do it with a minimum amount of fuss. Right. So, obviously, you can see we got stuff hooked up again. I just lodged that out of the way just to get it out. I could pull it out, but there's no point. This one is charging this. I'm thinking, right, okay, I need to make sure these batteries actually have a decent amount of charge. So I just hooked them up. I haven't actually, you can see that there's a power supply connected, but I've actually zeroed out the current, so it's not drawing current. It's just basically metering the voltage of the battery. The power pack is 120 volts max, which means it can charge them all in series. So I was thinking, why don't I just, because I want to make sure they're full first before I start bringing them into before I start using them essentially. Not full, but decently charged, right? And right now they're showing as 101.9, 102.2, depending on which one you believe. The voltage I'm sitting these is at 52, which is about 4 volts a cell. Max voltage is 4.2, so it's in the 60 to 80% region. I don't know where, but it's not 100%, and it's definitely below 80. And so what I want to do is do these the same. Now, I've obviously got them all in a big string, so I don't know about, how well they're going to be balanced, but at least it means that I can actually put a charge in them, and there's sufficient margin, if the difference is like 0.2 volts a cell, But right now they're just sat there. They've been sat there for quite a while, like, months, maybe even up to a year, and they have 102 volts. So obviously we're talking about a reasonable condition, and we're really only talking about bringing it up essentially 2 volts for the entire pack, which is right. So that's 30. So that's 26 cells. Yeah. So even if there's an imbalance, it won't go over the 4.2. I'm pretty sure. Well, it won't, obviously, because they're in reasonable condition. Even if one of them, so like for instance, if one is completely flat right now and the rest of them are all got good charge, so the reason why I've lost my 2 volts is because of something else. I'm only going to be bringing it up to 2 volts max, and the rest of them are going to get like, I don't know, 4.05 or something, which is fine. So I'm going to bring the current in. Now the wiring I've got is probably max 2 amps, but I don't think I'll need that. So let's bring the current in. 100 milliamps. I want to make sure it's capped out at 2. Oh, it's coming up pretty quickly, isn't it? Yeah, so it's already capped out to 104, right? And you can see it's drawing about 1.4 in order to basically do that. So that's fine. And you can see the meter says that too. Now what I want to do, just quickly, is transfer this to the half point, which is there. If I can get it to actually sit on it, that one maybe. I don't know. There. And you can see, 52.4. Now it's 104 for the full pack, but that's 52.4. So there's obviously a slight imbalance, but it could be just simply due to the wires. Oh, I haven't put that yellow one on. Now, the reason why I got yellows and reds is because these wires are a bit dodgy, so I just wanted to make sure that I had a connection. So I'm going to just leave it like that, essentially. I'll take the meter off, I think. And then that can then sit there, and presumably that will then drop right down to very close to 0, if not 0. Yeah. The reason why this is drawing actual power, right, all the time, 40 watts, of course, 38.7, is because the system that it's connected to is drawing the power. So that's essentially the power that's being drawn, 40 watts-ish, 3/4 of an amp, which eventually drains the battery. That's the problem, you see. You don't actually switch it completely off. So, and this is an issue with a system that's run like this. 3/4 of an amp drawn from 200 amp hours is obviously going to last quite a while. Okay, this isn't 200 amp hours. This is no, it's not. It's 40, yeah, 40 amp hour. 40, 80, 120. Yeah. Yeah, and if I actually had another 40, that would be 160, which would probably give it an equivalent range of the original pack. Like I say, 160 amp hours. In lithium, if you do the factor of, I think lithium, it'd be fair to say 80%. So if you have 160 amp hour, right, 80% of 160 amp hour is 140, isn't it? 140 amp hour. That is your available actual capacity in amp hours, right? 140 amp hour. The original lead acid batteries that were in it were 200 amp hour, but you only got 50% of that, which is 100 amp hour. So you obviously have more range. I mean, right now this probably has more range because it's got 120 amp hour. So I don't know, but it'd be interesting to actually get it out on the road and take it out and see how much range it actually has before it peters out. I've already done range testing on this. Yeah, basically by driving somewhere, turning around and coming back, and then seeing what charge was left, and then just doing it again further and further until when I came back it was cutting in at 20 miles an hour, which is its way of limping home. Gives you the excess range. At 20 miles an hour, this will have like 1,000-mile range or something stupid. Yeah, impractical to drive everywhere at 20, of course, but the option is there just to make sure you can get somewhere. Yeah, I might even charge those two up separately because I've got a 30 amp power pack as well, so I could put those two in series and do a 30 amp. In fact, why don't I take them upstairs and do exactly that? If I take these two upstairs, and then I can hook them up to a low voltage power pack, and then we can actually do a primitive cell balance, can't we? You know, a primitive BMS. Yeah.